Okie dokie. Share and okay. So here is situation. The new unit, or excuse me, the current unit Unit 5 and Unit 5 broken up into 3 chapters. Waiting for. Okay, so Unit 5 is broken up into 3 chapters. Okay, lists, loops, and traversals. And we've just finished lists, and we're moving on to loops. Okay, what period is this? Period 7. We actually aren't doing anything in lesson 5. There is a brief video in the lesson plan and in the student resources, but we've seen it before. We saw it when we did the digital scene unit, where it just shows, you know, a basic for loop and doing different turtle drawings, you know, however many times, which isn't how we are going to use loops here. We aren't going to do any drawing, but we are going to be doing the same things over and over again for a specific amount of time, for the amount of times that we want it to do a thing. And so that is what's going to happen. So this first lesson, which is the first lesson in the chapter lists, or no, that's not it. Wait, did I close the wrong one? I did not. I did close the wrong one. So we aren't doing lesson 5. It's a basic check for understanding that we haven't done enough. Like, I don't really agree with the way that they sort of throw you right in. I mean, it's not the worst thing to see where we're going, but I don't know if there's that much you can get out of these first 2 lessons. It's really just exploring some apps, but please follow along and explore with me. Go ahead to lesson 6, bubble 1. And we'll take a look at this really simple coin flip app that takes a number and you click on the coin and it keeps track of how many heads or tails, or rather how many heads and tails that coin flipping would result in. And if we go to bubble 2, we can actually see how it works. So the way it works is starting out with a bunch, we have our global variables at the top, but if you look at the whole thing, they don't really need to be global variables, because the only thing that happens in the entire app is this one event handler. The same thing down here. There is an update screen function, but it's only called in this one event handler function definition. So it really could just be like that. It's the same thing. I mean, not, this is just gibberish, but we'll leave it the way it is for now. So let's look at what we have. We have 2 variables, one for heads, one for tails, both starting out at 0, and another variable for total flips starting at 0, which, I don't know, could be done a different way, but this works fine. The key thing to notice is that this app is designed to be run several times without restarting. And the way that is accomplished is by the first thing that the event handler does is clears out those two variables. It resets them to 0 so that in our random number generating portion, we're starting from 0 and only counting the new heads or tails. Okay. Our basic loop is our basic for loop, where the most important thing for a for loop is the value you put in that position right there. Okay, this position, at least unless you change something else, this position is how many times you will do a thing. Okay, the other things are important for more complicated things, like if you want to start at the end of a list and go backwards, that sort of thing, that's what you would change. But for here, a basic for loop starts with the counting variable at 0, goes up 1 each time through, and checks to make sure that you haven't exceeded the number of times you want to do the loop. Now, this value right here has to be a number or a variable containing a number. Any sort of conditional that uses greater than or less than, you can only have greater than or less than, greater than or equal to, less than or equal, with a number. You can't have it against a string. So we either want to do it a hard-coded number of times or have a variable like we have here. Well, that's not a good sign. What room is up there? Let's call downstairs. What's the phone number here? How do you do 64928? Sure, go for it. All right, so we have our variable total flips, which is the only input from the user. And every time the coin is clicked, we're getting that new number. And so the number being held in that variable is the number of times we do the loop. Every time through the loop, we have a local variable here that is creating a random number 0 through 1. In AppLab, random number gives you a number between the two parameters you give it, inclusive, and it's always a whole number. In for real JavaScript, you'd have to do math.floor or .round to come up with a whole number. But here in AppLab, random number 0, 1 will only return a 0 or 1 with 50% overall average for each. Based on that random number that it gets, where it gets a new one every time through the loop, based on that random number 0 or 1, it then runs through this conditional where if the number is 0, heads goes up by 1, else tails goes up by 1. You don't have to check if it's 1 because it can only get to here if it is 1. It's the else situation in our binary. You'll notice, and we've done this before with plus plus is the same thing as something gets itself +1, just means goes up by 1. And same thing with minus minus, and we'll do both a bunch. I'll try to remember to do them in both ways. And the only output is updating the screen with the new value of heads and tails in the place. All right, so let's go on to bubble 3. So again, in the category of apps that are probably too complicated to fully appreciate how elegant they are. Here's another one. So what's happening here is we have a, I dragged this out a second ago. What's happening here is we have an app that takes a user's text input and updates several different, 5 different text outputs with whatever text we give it and whatever size we give it and whatever text color we give it. Okay, this is not terribly difficult to do. The clever thing about this is that it is using a loop to update the screen for several different design elements. These text outputs, notice the text outputs are all text 0, text 1, text 2, text 3, text 4. Because they are named that way, we can use a loop to update all of them in quick succession, which we'll do later in the project. This is incredibly clever and incredibly specific to AppLab. This is not a feature of for real JavaScript. It's not how you would update. I mean, I guess you could, but it's not how you would really update screens like that. But it is super useful, especially if you're doing a bunch of things or the same thing to a bunch of different elements, which we will do with the app at the end of this chapter, I think. And so up until now, we've done loops where the counting variable, the variable keeping track of how many times we've gone around, is just there to keep track of how many times we've gone around. But you can use that variable. In this case, the variable is called I. There almost always is called I if it's a for loop. You can use that variable inside the loop as some other control device. In this case, because all the text areas are text 0 through whatever, does somebody want to run up to the room that's above us? All right, so because the first time through I is 0, it's setting the property of text I. It's concatenating the value of I with the word text. So it's setting the property of text 0. The second time through I is 1. So it's setting the property of text 1, and so on. It's super clever, but super specific to AppLab. And we will use it once later. And if you don't understand it, that's fine. And the check for understanding, we can hang off on it for now because we don't have a lot of experience. Again, I think this is another question that is before it's time for you guys. But okay, think back on the font tester app. Can you think of another example of an app feature we control the loop? We haven't really done enough with this, so we're going to hang off on that. All right, so let's go to, and now we're going to start doing stuff. Lesson 7. Lesson 7, bubble 1. Yeah. Okay. Lesson 7. Did we skip bubble 3? Bubble 3 was the. Yeah. We're good. So lesson 7, bubble 1. All right. So here we are starting with while loops, and while loops are functionally identical to for loops. They have all the same features. They're just written out differently. Okay. So a for loop we've seen before starts with declaring a variable. It's almost always the letter I is the variable used to count. It declares it at 0. It has a condition for ending the loop. When I gets to 4, don't do the loop anymore. And every time through the loop, I goes up by 1. So we'll do it 4 times. A while loop has the same setup. It starts by declaring a variable that will be used in the conditional that will end the loop. Because it's while this statement is true, do what's in the loop. And inside the loop, some stuff happens. And it ends with, and it doesn't have to go at the end, but things would be weird if it didn't. It ends with incrementing that counting variable. In this case, we've named the counting variable counter, which is fine. A little on the nose, but it's fine. And every time through, counter goes up by 1. And so the first time through, counter is 0. While counter is less than 10, 0 is less than 10. It runs, it's going to console log the value of that variable. Then counter is going to go up by 1. And the next time through, counter is 1. It checks, is counter, which is 1, less than 10? Yes. And it keeps doing that till it's 9, goes through, adds 1, it's 10, it goes back up and checks, it's 10, this is not true, skip and end the loop. Okay, and that's why it is less than, not less than or equal to 10. It will end once it's 10, which is, if you're starting from 0, is another way of saying do it 10 times. Just understand the format at the very least and use it. So, do we have to do anything for this? Okay, so the way that it comes to you is it will print out 0 through 9. Okay, because inside the loop, it's using that variable in our console log statement. They want you to change it, so it prints out 0 to 99, which even if you had no clue what was going on, you'd be able to figure out to do the loop 100 times. And it will print out 0 to 99 as intended. And let's go on to bubble 2, which is the same thing, except printing out the string hello, and that they're using plus plus instead of counter gets counter plus 1. It's the same thing. We're still incrementing by 1. And instead of printing out the word hello 10 times, they want you to print it out 100 times. Which again, this shouldn't be that challenging. This is not super difficult. Okay, bubble 3, some more while loops. So in this app, we get a, it's just console log practice. There's no interface, but we get a set of code, chunk of code that will give us the result of 10 coin flips in the form of a list with 10 items, all of which 0 or 1. Okay, we are just sort of inferring that the 0 and 1s are heads and tails or tails and heads. It doesn't matter. The way it's doing that, we're starting out with 2 global variables, a variable used for counting and an empty list. We then run a loop 10 times. Each time through, we are appending an item to the list called coin flips, and we're appending either 0 or 1. In the past, and we probably will still in the future, we'd have some sort of variable that will get a random number, 0 or 1, and then we'd have that variable posted but you can do it all at once on a single line, like the way they show you. And the variable counter goes up by 1. The variable called counter, which is our counting variable, goes up by 1, and then it checks and ends the loop when counter is 10, which would be the 11th one. Again, more count from 10 fun. And count from 0 fun. We have to do the same thing, but with dice roll, or rolling a die. And or we'll roll 10 dice, or I guess 1 dice 10 times. It doesn't really matter. We get a variable counter 2 starting at 0 and an empty list called dice rolls. We want to do a loop. So we'll do a while loop, and we want the while loop to continue so long as counter 2 is less than 10. And before we forget, you need to throw in whatever is going to end your loop, because if you don't have a way of changing, if you can't change something in the conditional, it will go on forever. Okay, so it's either counter 2 gets counter 2 plus 1, or counter 2 plus plus. Okay, well, okay, thank you. So, all right, so we have our loop, our while loop. Counter 2 goes up by 1. So what do we want to do each time? Well, just copying the format of the other one, we can just do an append item. Append item, the 2 parameters are the list and the item we want appended. The list is called dice rolls, and the item we want appended is a random number. And every time through, we'll get a new random number that needs to correspond to a valid dice roll, which would be 1 through 6 inclusive. And then we just have the output, which I think this should work. Yeah, so then the output is a list of integers between 1 and 6, which corresponds to dice roll. Okay, these are pretty basic. Hopefully you understand. All right, so this bubble 4 is 2 activities. They are pretty easy overall. They aren't as difficult as the other putting it together multi-practice bubbles that are towards the end of the list, which, do we have another one? No. Okay, so yeah, this whole lesson is a little dry, but that's fine. You need the basics. Okay, so what do we have here? We want an app that will roll 2 dice, roll a pair of dice 100 times, and tell us how many times doubles were rolled. So how are we going to do that? Well, we definitely are going to do something 100 times. So we need a loop. Hi, this is Mr. Holt. I've been in 223. We are having coming through the ceiling, and probably need somebody to, it's a, I wouldn't say a terrible one, but it's weird. And yeah, and we at least need some tarps for temporary, or something to cover it. It's like a plastic. Okay. Thank you. All right, so that's fine. All right, so we have, where was I? Okay. So we're going to do something 100 times. We're starting. Okay, so we're going to do something 100 times. What are we going to do 100 times? Well, we need to come up with two random numbers, a new random number for each of the two dies, 1 through 6, and every time they match, we want to note it. The way we're going to note it is with another variable that's going to keep track of that. So how about, let's call that variable doubles. It's just going to be an interesting replay. It's the only one we're doing. Doubles. And we'll start at 0. And if we were doing something where the user would click on the screen multiple times and we want multiple outputs, we'd have to reset doubles to 0. Actually, no, we wouldn't want reset. Never mind. Okay, ignore that last part. Okay, so we have some way of keeping track of the number of doubles. Next thing we need to do is sort of define our loop. Our variable called counter is going to go up 1 each time. We need to tell it when to end, or rather continue so long as, that's what while means, continue so long as counter is less than 100. So 100 separate times, we are going to give each one of these variables, roll 1 and roll 2, a new random number. So how are we going to keep track, or how do we know, how do we keep it? I'll just say. So we need to check to see if they're doubles. So how do we know if they're doubles? Well, if roll 1, and this is the numeral 1, and this is lowercase l, even though they look identical in this font. If roll 1 double equals roll 2, then we want our doubles variable to go up by 1, and eventually we get a blank plus block, I think. But until then, we just want doubles plus. You can still do, doubles gets doubles plus 1, but we'll leave it like that. Okay, so if roll 1 is equal to roll 2, doubles goes up by 1. Otherwise, it ignores this, adds 1 to our counter, and runs the loop again, so long as we're less than 100. And when the loop is over, this variable doubles will keep track of how many times we've matched, and we just need to output it. So we're going to end with a console log of doubles. So now when you run it, we should get the number of doubles for 100 rolls is 21. And if you run it a bunch of times, the average should be somewhere around 18. And if you're getting a number other than 18, or, other than the high teens, you've done something incorrect. But most likely you just have no output if you're having trouble with that. But that's what that looks like. So we're doing a loop, and during that loop, we have a conditional. And regardless of that conditional, we increment the counting variable. So we only do it a certain number of times. If we had the counter inside of here, counter would only go up when we matched, in which case it would only end once we had 100 matches, which is not what they want here. So never mind. Okay, back to 4.b, countdown. Okay, so far we have only gone through loops upward. Okay, starting from 0 going up. And that's most common way of doing things. but you can go through loops backwards. Okay, in a for loop, the backward situation would be changing. You need to change the starting value and you change the condition. So while I is greater than whatever, and it will go through a loop backwards. Super useful when you are looking at a list. And we talked about this before with when you're removing items from a list, you have to go through it backwards because as soon as you remove things, everything gets shifted. So that's how you would go backwards, is you change the starting value of the variable. And that's what we want to do here. We want an app or some code that will get a user input of a positive number and then print out a countdown from whatever number they put in all the way down to 1, and then print out the word blast off. This prompt num command, when you hit run, you will get a not an alert, but a prompt that asks the user for a number. And this is a hello. Hi. Right over here. It has stopped temporarily, but it stopped 3 separate times. All right, so we have a way for the user to put in a number. And with that number, we want to do a loop that many times. And the way we're going to do that is, what is our end condition? That's what the while is. We're starting with a high number. We're subtracting 1 every time through the loop. We want it to end, or rather, we don't want it to go on when counter gets down to 0. So we're starting with a positive number, whatever the user gave us. And we're going to go so long as we're above 0, because we don't want it to be 5, 4, 3, 2, 1, 0 blast off. We want it to 5, 4, 3, 2, 1 blast off. And before we forget, we need to make sure we have our portion of the loop that changes the condition or the conditional variable. And in this case, we're starting with a positive number and we're going backwards. So we want counter to go down by 1. Counter minus minus means that we're going to go through the loop however many times of a number they give us. And each time we want it to print out the value of counter. So starting with whatever number they give us, will be above 0, hopefully. And we will print that out, and then that variable will go down by 1. The next time through, we're checking, and it will print out that value of that variable, which is 1 less than when we started, and keep going around. So we're actually using the counting variable in our program. I mean, just barely. It's a console.log statement. But we, so let's see what happens when we run it. I think, okay, so we need an input from the user. And as we loop through, it will print out that much. As far as the last portion, the blast off portion, you could have some sort of conditional where it's like, if counter is equal to 0, that we don't have to overthink it, just print out blast off. And so now whatever number you put in, it will do 7, 6, 5, 4, 3, 2, 1 and blast off. All right. The point of this is just working through a loop backwards, or having your counting variable go down until you get to 0, either way. And also using that counting variable in the programming. Although again, just barely, we're doing a console.log statement. All right, bubble 5. No, that was 4. Is there a third one? No, we did that. We did both those. All right, bubble 5. We have, now we're going to use a for loop. We've talked about for loops before. and we've done much harder stuff than this before, where same basic thing, and we talked about this before, where the only thing that really matters is the value you put in right there. In fact, the older versions of the for loop only had a blank right there, because until you get much further along, that's the only value you need to change. Although I suppose you could do a J loop if you wanted two-dimensional, whatever. Either way, this is just a for loop that's going to happen 10 times, and it's going to print out the value of I every time through to show you it changing, which is what happens here. I'm not sure if we actually have to do anything here. Create a variable, assign starting value, and do this. Read the program. Print 0 to 99. So we want to print out, we want to stop when it gets to 100, or continue so long as I is less than 100, which is how you get 0 to 99. And speed slider all the way up. All right, so nothing super new there. Bubble 6. Excuse me. Yeah, bubble 6. Okay. Your for loop doesn't have to count by 1. If you wanted to print out even numbers or multiples of 3, you can have I go up by however much you want each time. Okay, the default is I++, meaning goes up by 1, but you could do I gets I plus 3, in which case 20 times it's going to print out the value of I, but each of those 20 times I isn't going to be the 0 through 19. It's going to go up by 3 each time. Oh, no, it's not. It's going to go up by 3 each time, but it's not doing 20 loops. It's stopping when I gets to 20. If you wanted 20 loops, you would still do I times 3, whatever. Okay. The more common way you would see, okay, so something gets itself plus 1 goes up by 1, which is the same thing as whatever plus plus. If you want to go up by a certain amount, you can do plus equals is the short cut for that. Plus equals means gets itself plus that amount. So what I have there is exactly what you got when you started. I gets I plus 3 is the same thing as I plus equals 3. And hopefully, yeah, still works. And you can do times equal. Okay, if something gets itself times 2. Very common when you have something like bouncing around a screen and it gets all the way to the right side and you want it to bounce, you would have its velocity get itself times -1, which is how you would change direction. So it would be whatever, velocity times equals -1, gives you the inverse or reciprocal or whatever. So there's a lot of ways to use it. But here we want to print even numbers between 0 and 100. So we need I to get itself plus 2. And we want to do 100 loops, or rather do loops so long as I is less than 100, which is that. Between, I mean, I'm not terribly concerned with if it starts with 0 and ends with 98. I don't know if it counts 0 and 100, but you can start I at something other than, oh no, it would be 2. So we start at 1, it would be all the odd numbers. Never mind. Don't overthink it. Okay, bubble 7. Okay, so we have, this is a app that is creates 2 lists. Okay, so we are doing 1 loop and we want to do the same thing to each of these 3 lists, or rather we want to do something to each of these 3 lists the same number of times so it can be put all in the same for loop. In this case, we just want to append item to, and in fact, it's easier just to, we want the exact same thing. And flips 3. And there you go. So again, nothing outstandingly complicated. A lot of you pattern seekers would be able to solve this without even knowing what's going on, but that's fine. Okay, bubble 8. All right, so here we have an example of that situation I said before, where they are very cleverly using the loop to change the property or set property for several different elements, all in the same loop, because they've named them, you know, text 0 through text 3 or something like that. Is that what they call it here? Or they call it label 0 through label 3. Okay, because the set property block, the first parameter is the ID of the element expected as a string. And if you concat the word label with the value of I each time through, it will be label 0 through label 3. And here, each time through, we are setting the text color to a random color, which is RGB, but random 0 to 255 for each of the 3 color channels. So it should come up with a completely different color for the text for each of them. Now, the way this works, it's setting a new random color for each one, because that random color is being created each time through the loop, where you could create a random color at the beginning, where it'd be like var rand color, and give that variable our RGB something something something, and then set the property to rand color. And this might work, it might not. Oh yeah, it's working. Okay, so this is giving that same color to all of the places rather than just a new random color each time through the loop. So where you are assigning the randomness is important. We want here to have it change the size. Yes, so we want it to change the size also. And we want it to change the size when we click the randomize color, randomize button also. We don't need a different button. But in order to do that, well, we already have a loop that is going to talk to each of the items. So we don't even need another loop. We can do set property of label plus I, label in quotes, and then after the quotes plus I. And we want to set label plus I, set its text size. Is it font size? What is the icon size? Font size to a random number. Let's see, what is this? 14? Is that what we're starting with? So 14 is sort of a lowish one, but we need a random number that would be a valid, or a random number range that would be a valid result for font size. So maybe 10 on the small side, and I don't know, 24, something like that, something reasonable. And when we click randomize now, each one gets a random color and a random size. So there's that. And I think that's it. Okay, bubble 9. Okay, so we have, by combining the iterator, the counting variable, with strings, which is what we did before, we can change the properties of many screen elements at once. So here we want the dice to roll, and we want every single one of these to get a value of 1 through 6. And we want also to keep track of how many were even, and we want the even ones to get a white border. This is actually kind of complicated, or rather, there's a lot of factors going on. So far, we only have a roll button, and actually, that's fine. That's the only thing we need. If we don't have any other function definitions, we don't need global variables. Everything's just happening here. And so we want to keep track of how many are even or odd. And we don't need a variable for both of them, because one is going to be the value of whatever it is, and the other is going to be 20 minus that number. So it doesn't matter which you keep track of. In this case, I guess we're keeping track of odds. And we definitely want to do things 20 times. So even changing that one thing will give us a full set of dice. And each one's getting a random number, 1 through 6. We're setting the property of each of them to that number, followed by the border width. Problem is, we need to protect that border width. Okay, we have a conditional here checking for odd. Okay, if roll is 1, 3, or 5, it's odd. And well, we can just go ahead and have an else, and anything in the else will be if it comes up even. So not sure how we're going to use it yet, but I'm sure that'll be useful. Well, we definitely I know I said before we don't need an evens variable, and the truth is we don't, but it might be easier to understand what's going on. So let's go ahead and make an evens variable. Evens variable starting at 0. And our else condition will have evens go up by 1. Evens plus plus. And at the very least, our text output is going to be, total odds followed by the variable odds, followed by new line total evens, and then after the quote, but before the parentheses, plus evens. Because that is, I'll show you in text mode, it'll be a little easier. That is the concatenation that we want. We are concatenating the phrase total odds, then the value of odds, followed by new line command total evens, followed by the variable evens. So we should be able to get numbers that work. And the only other thing that we need to do is we only want the evens to have a white border. So we can bring this set property down to evens, because this is going to be, this whole else is the evens condition. We give evens a white border, but we need to make sure that the odds don't have it. So we are going to set the odds border to 0. So every time through, it's correcting itself. Because if we did not have this, then anything that was ever an even would stay with a border, which, there we go. So this one wasn't even on the previous one, but it's not now. So yeah, so we want that. And just for fun, we can make the border one, I don't know, a little bigger so you can see it. And there you go. There's some dice roll. I think that's the last one. Yeah, check for understanding is all that can go on. And let's take a look at those. They're just some basic, super awesome pseudocode questions. And so we have some loops. Loops in pseudocode are not as frustrating as lists in pseudocode. It's just a simple do this n number of times. It doesn't matter. That's the equivalent of a for loop or whatever loop. Repeat until is the same as well, it's actually the opposite of while loop. Sorry. That is kind of unnecessarily complicated, but it's written out in close to plain English. So repeat until, this is the stop condition. Our loops were while loops, which was the continue condition. They're the same thing, except the opposite. Okay, so we have a question. What will be displayed after this segment is run? So let's work through our variables. And what's that going to look like? So we have a variable called count, starts at 0. Great. Okay, repeat until count is 3. So we'll do it so long as count is less than 3, right? Okay, so the first time through, count gets 1. We are getting 1 before anything happens. So count is already 1. And then we want to display and then the value of count. Okay, second time, count is still 1 the second time through. So we keep going. Count gets count plus 1. So count is now 2 second time through. We display and then the value of count. Okay, count is still 2. We go back up. Count is 2. We keep going again. Count goes up by 1. So now we're at 3. We display and the current value of count, which is 3. We go back up. Count is 3. So that ends it. So I'm hoping this is one of the results. Is it one of the results? Where are the results? There we go. So yeah, there you go. And 1 and 2 and 3 should be the result for that. I know that wasn't the tidiest writing, but let's see what we've got here. We've got another loop that repeats 3 times. That's all you need to worry about. It does it 3 times. A is starting at 0. Okay, that's the value of A. A gets A plus 1. A is now 1. Display A. Our first display is the number 1. A gets A plus 1 again. So A is now 2. Second time through, A gets A plus 1. A is now 3. Display A. A goes up by 1 again. A is now 4. That was 2 times through. Third time through, A gets A plus 1. A is now 5. Display A. A gets A plus 1. A is now 6. We've done it 3 times. This is the output. Okay, hopefully that's one of the answers. Yeah. And hopefully you get something from me telling you the answers as sort of like how to solve problems for the AP test, this type of thing. All right, so I know it's a lot, but the replay will be up shortly. And